discussing about reciprocity condition of two-port network, and we have found out for a given two-port network conditions which must be satisfied if it is Z represented, if it is Y represented in terms of admittance matrix, or if it is H parameter way it is represented. And of diagonal elements, some conditions are there, Z 12 should be equal to Z 21, similarly Y 12 should be equal to Y 21, but for H parameters there is a slight difference which should be once again H 12 H 21, but H 12 should be equal to negative of H 21. Now, today I will discuss condition for reciprocity of a two-port network, condition of reciprocity of a two-port network when represented as ABCD parameter or transmission line parameters as ABCD parameters, as ABCD parameters. What relation ABCD parameters looks like? That is ABCD parameters, you know, this is ABCD. From the other two, you may be tempted to say maybe something to do with the off diagonal elements B should we see, we will see that what it is really. In fact, it is not B equal to C. Let us see that. So, first of all draw the two-port network and write down the general equations, fundamental equations. That is, if you apply a voltage V 1 here, this current is I 1, and here the voltage polarity is V 2. But as I told you, in case of ABCD parameters, which is also called T parameters, transmission line parameters, ABCD parameters are also called transmission line parameter. And usually written as T, that is T is equal to this, this is T. Okay. Anyway, so this is the general thing I have drawn, but while drawing this I should be careful about this I 2 fellow. It is assumed always positive when it is going out like that. And then the input quantities, basic equations are V 1 and I 1, sending end voltage and sending end current of a transmission line is represented in terms of receiving end voltage and receiving end current, that is A V 2 plus B I 2 and C V 2 plus D I 2. This is the thing. This is a fundamental equations. Good. But once again I have to find out V 1 by I 2 relation. Therefore, first what we do is this, find V 1 by I 2 with V 2 is equal to 0. That is, for this from which circuit this is to be found out? That was the general circuit, that is V 2 must be made 0. So, I will short circuit it, V 2 is 0, I 2 mind you this way, and this is you have applied a voltage here V 1. So, from this network I have to find out V 1 by I 2 this ratio. And how can I find it out. So, V 1 by I 2 I will point out. So, V 1 by I 2 I find out. Okay. And this ratio if I want to find out V 1 by I 2. So, from the first equation I will say that look here V 1 by I 2 okay, straight. So, this first equation will then become how much? V 1 is there from the first equation, this V 1 is equal to A V 2, that is 0 plus B I 2. That is very nice, because I want to find out V 1 by I 2 and I have got it. So, I will keep this V 1 by I 2, that is the transfer impedance I have to calculate whatever it is V 1 by I 2, and this will become equal to B, and keep this. This is an important result. Achha. Then what I will be doing is I will excite this output port with a voltage V 2 and keep this side shorted, and I 1 correct direction of current, as I have told you, it is specified in this way. I should not play with this, but anyway you excite this with V 2, short circuit this, V 1 is equal to 0, clear. Now, I calculate V 2 by I 1, but do you think that V 2 by I 1 should be equated to V 1 by I 2? No, because you have energized V 1 and shown this current to be coming out I 2. Therefore, you have applied V 2 here, current in the other side in this direction is minus I 1. I should take this ratio then, that is what important. So, anyway, first calculate V 2 by I 1. That is V 1 by I 2 in this case, because of this thing. See, the direction of I 2 in this case and the direction of I 1 should be consistent, that is the ratio, that is what reciprocity theorem tells us. So, V 1 by I 2 I have calculated, I will keep it. In which mode? This is V 1 plus minus and current is coming out from this output port. Similarly, I have energized this with V 2 and but I 1 I 2 is specified like this. So, I must look forward for V 2 by minus I 1, and this should be equated with V 1 by I 2. Anyway, let us see what happens. So, that is the thing. With this thing, if you come to the from the, so V 1 is equal to 0. So, first equation will give you 0. This is the second experiment we are doing, put a horizontal line here. First experiment is over, second experiment, but this equation is fundamental. V 1 equal to 0 should be equal to A into V 2 is not 0 plus B I 2. This will be there, and the second equation is I 1 is there, which is equal to C V 2 plus D I 2, nothing is 0 here, but you want to find out V 2 by I 1. So, first divide by I 1 both sides, any mistake point out. So, I 1 you divide. So, if you divide I 1, it will be 1 is equal to C into V 2 by I 1 plus D I 2 goes. Is it correct? D I 2 by I 1. because I have divided this to this OR. Now, who will give me this I 2 by I 1 business? B 2 by I 1 I have to do. So, if you divide B 2 by this is 1. That is what I have to do. So, what I will do is this, instead of dividing first, this I 2 I will represent it. First, let us see. See, in this equation B 2 by I 1 is necessary. So, from this equation I will find out I 2 as minus A by B into V 2. So, that this equation I 1 is equal to C V 2 was there plus D into I 2, and for I 2 I will put minus D A by B into V 2, is not? This is the thing, and this will be equal to B C minus A D divided by B into V 2, or I will say B 2 by I 1 is equal to B by B C minus A D. That is what I will get. But the question is here, because this I 2 I have defined in a different way. For one experiment you have found out, you have excited this side, got the current this way. So, to have the networks satisfying reciprocity, same polarity of voltage I have applied on this side, but I should take the current in the same way, is not. So, I should not equate V 1 by I 2 is equal to V 2 by I 1. What it will be equated to? It will be equated to for the this quantity, for the reciprocity condition, we must demand that V 1 by I 2 should be equal to V 2 by minus I 1, that is what I require, which is equal to minus of V 2 by I 1. This is very important to note, because what happens, ABCD parameters are defined like that, all people are following this, that is the convention. Because of this thing happens. Therefore, I will say then B 1 by I 2 is B, B should be equal to minus V 2 by I 1, that is minus B by B C minus A D, which means that B by A D minus B C. B B goes, and I will say A D minus B C should be equal to 1, that is the condition. Therefore, if a network, two port network is represented in terms of ABCD parameters, B and C alone does not decide whether it is off diagonal elements same or no, the condition is totally different. It says that determinant of this matrix ABCD, determinant, this must be equal to 1, that is the condition. Got the point? Therefore, if it is represented in terms of impedance matrix, Z12 is Z21. If it is in terms of admittance matrix, Y12 should be equal to Y21. If it is H parameters, then also H12 and H21, but H12 should be negative of H21, and if it is represented in terms of ABCD parameters, this is the condition, final condition. Got the idea? So this is how it is to be found out. See, reciprocity property, you must as I was telling, if somebody says that one should not be under any doubt about this step, that is what I am telling. If somebody says here is a network and you apply a voltage here V 1, forget about this two port network, V 1 you have applied, and you record this current in this direction I 1. Calculate this ratio V 1 by I 1. Now, what I am telling, if the same network, if you excite keeping the voltage polarity same with V 2 and short it and tell this current to be also I 2 like this, then there is no conflict, everything then V 1 by I 2 should be equal to V 2 by I 2, V 1. So, current is coming in, here also current is coming in. In case of ABCD parameters, what has happened, if somebody says that this is V 1, V 1, this is I 1, and somebody says that I 2 I will take like this. Calculate V 1 by I 2 of this. But then in the second case, this is V 2, this remains I 2, but this current is of interest, transfer this voltage and divided by this current. This current, if somebody says during this, this current is I 1 when you short it, because direction of current is my prerogative, I will choose the way I like. Then this impedance V 2 by I 1 if you calculate and equate it to V 1 by I 2, that is not fair, that is not correct, that is what I want to tell. What you should do, V 1 by I 2, oh that is fine, that is fine. So, V 2 by I 1 in this way if you assume, that is okay. So, I think you have got the point. Any doubt? No, hopefully not. Okay, that is fine. Achha, after I have done this, now the question is, you will be able to solve several problems. Okay. Today, I will tell you an interesting thing, that is, suppose a two port network is reciprocal. Okay? We know what it means. Therefore, if represented in terms of Z parameters, have represented in terms of Z parameters, then these equations are true. So, reciprocal, so I know that then Z 1 2 is equal to Z 2 1, that is what. So, V 1 is equal to Z 1 1 I 1 plus Z 1 2 I 2 and V 1 V 2 is equal to Z 2 1 I 1 plus Z22 I2, is not? But in that case Z12 is equal to Z21. Okay. So, this equation, then writing matrix way it is okay. So, I can replace it this one by Z12 itself, off diagonal elements will be same, that is what we have found. Acha, let us look at the first equation. V1 can be written as Z11 I1 plus Z12 I2, that is fine. Then I will just manipulate this equation a bit. This way I will write Z11. Oh, I go step by step. So, I will write it is equal to Z11 I1 was there. Then what I do, I subtract this term Z12 I1 and add the same terms. Like this, I can do that, everything remains same. Now, this V1 then will become Z11 minus Z12 into I1, and this one will be this one will be Z12 into I1 plus I2, is not like this. So, keep this as equation 1. Similarly, you play with the second equation. What you do, that second equation V2 is equal to Z22 I2. So, you write Z22 I2, then subtract Z12 I2 and add Z12 I2, so that it remains same as it was, and finally, the first term is always there Z12 I1. Therefore, it can be written like this, that Z22 minus Z12 into I2, these two terms, and this one will be plus Z12 into I1 plus I2. Let this equation be 2. Now, if it is like this, then this 2-port network can be, because see, in this 2-port network, what I told, I do not know how the impedances are connected, actual networks. We have shown with some example earlier, that plus minus V1, these are the terminal voltage currents I am only measuring and trying to model in my own way, whether Z parameters, H parameters or things like that. That is fine, V1 I1, V2 I2. Now, and I find out the parameters, and I am told that it is a reciprocal networks. So, in that case Z12 must be equal to Z21. Therefore, this basic equation can be written like this, that is I highlight these two equations, that is this equation and this equation. Achha, looking at this equation, I will say that inside this network, I can presume that the network is a T connected network Z11 minus Z12, and this one, these are impedances Z21, Z22 minus Z12 and here Z12. These are very interesting results. And see, earlier it was unknown how these impedances were there, but what I am telling, it was a black box. I found out this and also concluded it is a reciprocal network. During the course of experiment, Z12 came out to be same as Z21. I concluded it is a reciprocal network. If it is, then I am telling manipulate these two equations in this way. Then you see this is your V 1 you are applying, is not, plus minus. This is your V 2 you are applying, this is also plus minus. Now, this current I 1 is like this. So, what is this current? I can think it is I 1 goes in. Similarly, this current V 2 I always assume in this way. So, this current is going like this. That is, this I 1 I 2 can be thought of to be a loop current of this network, of this T network it is called, it looks like a T, where the elements impedance values of this one is Z11 minus Z12, it is Z22 minus Z12 and Z12. You see this, what is the loop equation here? The first equation, look at V 1 is equal to Z11 Z12 into I 1 plus what is the current flowing through this branch? I 1 plus I 2 into Z12, and these two voltages must balance V 1. That is what exactly I am getting. Similarly, in the second loop, applied voltage is V 2, it will be equal to Z22 minus Z12 into I 2. But what is the current flowing through this Z12? It is I 1 plus I 2, I 1 plus I 2 and I 1 plus I 2 into Z12. So, this then tells me that okay, you may not be knowing the internal structure of the impedances, how they are connected, but if it is a reciprocal network, you can always think this network is nothing but a T network with these parameter values. Are you with me? That is, I am now telling something more. Inside this, I can now think of it is a network like this. Got the point? Which was hitherto not known to me. And once you do this, let me be in this page only. Once you do this, see, the interesting part is, these are the ports, these are available to me, and inside now I can think okay, it is a T network of this form. If it is like that, these three impedances are connected in star. I could also, if I wish, this star I will represent it by some delta impedance, because I now know the parameter values here, there. So, I can also represent it by an equivalent. Let me go to next page. So, I have got this thing. I do not bother how complex the network was, but ultimately I have shown that if this is the supply voltage, this is the current I 1, you can represent it as this is Z12, no, and this is Z22 minus Z12, this is I 2, this is I 1, and this current is I 1 plus I 2, and so on. We have seen that. Okay, let me not put too many things here. and all the parameter values are known, this, this and this. Now, what I am telling, these three impedances are connected in star. Therefore, I can replace this by some equivalent delta. These are the 3 points about which I can do the star delta transformation, and I will put it like this. And erase the blue terms. So, this star connected networks, that is these 3, that is a good thing, Z11 minus Z12, Z22 minus Z12, and this is Z12. With respect to these 3 points, this can be, these 3 points are, I cannot touch, they are 3 terminal 2 port network. This can be drawn as a circuit like this, is not? That is what I told you. This is my input port and this is my output port, input port remains same. Or with respect to input and output port, you can draw it like this. So, I1, V1, this is V2 and this is I2. What will be the value of this impedance? Star connected rule I will apply, is not? This plus this into this divided by this. So, I can always find out these values also. Therefore, I am telling that in essence, generally all the networks will be bilateral and linear networks, and no matter how in a complex way the impedances are connected inside this black box. If you tell me the value, I will always tell that okay, this network can be represented as a T network if it is like this. This is the T representation, T network, T representation, T. This is not with ABCD parameters T representation. Or you can say it is a pi representation. Do I know the values of these impedances? Yes, I know, because I know these values and vice versa. Therefore, remember how whatever complex way the impedances are connected inside, eventually you can, with respect to the input and output ports, you can consider to be some lumped parameters connected in T fashion or delta fashion, pi fashion, and this is widely used in power system sort of representation. And we will continue further with our discussion. What do I mean by series parallel connection of 2 port networks in my next class? Thank you.